Okay, so we're going to split section 3.4 up into two parts. The first part will be solving rational equations. And we're just going to jump right into an example. So how can we solve, and we're going to solve the rational equation x minus 5 over x squared minus 3x minus 4. And we're going to solve when that equals 3x plus 2 over x squared minus 1. Okay, so looking at that, what's the first thing that kind of comes to mind? Maybe our first step that we could make to solving this. Okay, if we can factor out of the denominator, that'd be great. So how can we factor either left side or right side? How can we factor the denominator? It's a difference of squares, so how's that going to factor? Okay, our right side can go into x plus 1, x minus 1. And how about our left side? Okay, x minus 4 and x plus 1. Okay, so this is good. We factored it. And what do we notice about our denominators now? They're different. Is there anything the same? Okay, they both have an x plus 1 term, which is going to end up helping us in a step or two. Before we even go any further, what are our restrictions? Okay, so we have x can equal 4, x can equal plus or minus 1. It's always good when you have unknowns in your denominator, if you can write out with some restrictions. It's a good habit to get into. Okay, so looking at our equation, how are we going to solve this? What could be our first step in solving this equation? So our first step in solving this problem is, all right, well, let's see if we can make it easier on ourselves. We could move things over to 0, but what's giving us trouble right now is the fact that we have something in our denominator. Okay. What I would do first is let's try and get rid of the denominator. So we're going to multiply both sides of our expression by our denominator. So our first one I would multiply by, well, let's multiply everything by x plus 1. If I have a term that both sides have, let's multiply that by first, because things are going to cancel out. It's going to make things easier. So here I can cancel. These guys are going to cancel out. They're going to cancel it over here, and I can get an equivalent expression of x minus 5 over x minus 4 equals 3x plus 2 over x minus 1. So now we have an equation with one term on each side. Both terms have a denominator. So what we can do is cross multiply out our denominators. And we're going to get x minus 1 times x minus 5 equals x minus 4 times 3x plus 2. Okay, this is as far as we can go right now without moving things over. So let's expand these out and see what we have. If we expand out our left side, we're going to get x squared minus 6x plus 5. And on our right side, we'll get 3x squared be minus 10x minus 8. Okay. And now we're at a point where we can bring everything over to one side and set it equal to 0. So we can say 0 equals 2x squared minus 4x minus 13. Okay. And now we're left to solve that. So we have a quadratic in standard form. Can we factor this? We're looking for two numbers that multiply to negative 26 and also add to -4. Okay, doesn't look like that's gonna happen. So what are we gonna do now? If we can't factor it, what do we have to do? What do we use? Okay, we're gonna use the quadratic formula. So we're gonna say no factor. Therefore, we have to use quadratic formula. And we're doing that when A equals 2, B equals -4, and C equals -13. Okay, so we go to our quadratic formula. And we can sub in. Okay, so we can plug in our numbers. We can work it out. We get 4 plus or minus the square root of 120 over 4. Now, you could just plug this into your calculator and get a couple answers. I'm going to show you a couple other steps that you could take to make your numbers a little bit smaller. Okay. Now, what you could do at this stage is notice that 120, if we can express 120 as a product of a perfect square and another number, we can take the square root of that. So what I mean by that is if we can say that 120 is 4 times 30, okay, over 4, then what you would do from there is you'd say, all right, well, let's just take the square root of 4. What's the square root of 4? Square root of 4 is 2, so we can express our answer as 4 plus or minus 2 root 30 over 4. Then you can look at the numerator and say, all right, I have two terms here. I have a 2 and a 4. Can I factor out something from those? You can factor out a 2. So our numerator can be expressed as 2 bracket 2 plus or minus root 30 over 4. Okay, and then you're looking at that. Can I reduce 2 over 4? And you can divide them both by 2, and we can get an equivalent expression of 2 plus or minus root 30 over 2. Again, you would get the same answer if you just calculated from here, but this is just some further steps that you can take. So from here, you can say we have two terms or two solutions. Our first solution is when x equals 2 plus root 30 over 2, and our second solution is when x is 2 minus root 30 over 2. And then we can get if we want a decimal answer for those, like a numerical answer, we can calculate those as well. Okay, so if we're looking at this, we now have a couple solutions. Okay, we have a solution of 3.74 and negative 1.74. Both of those are not one of our restrictions. So to go up to the top, both of those fit into our restrictions, so our solution is valid. So we've solved that. What's another way we can solve this problem? So here we solved it algebraically. What's another way we could solve that problem? Okay. Another way you could do that is if you graph them, you could find the points of intersection. So to do that, you could start off graphing each one of these, so treating the left side as a function, treating the right side as a function, graphing those, and finding the points of intersection. You could do some work, get a simplified expression, graph this, Okay, and find the zeros. Okay, but on like these ones are not super easy graphs, and we, judging by our intercepts that we found, our zeros that we found down here, I'm going to guess that your graphs aren't going to be accurate enough to find a zero of exactly 3.74 or negative 1.74. So you'd probably using your graphing calculator, looking at finding points of intersection or zeros from that if you're looking at doing a graph, or you're going to be doing algebraically using the quadratic formula.